Good morning everyone. I'm Teja. Today I'm going to give seminar about sequential circuits. Sequential circuits are the foundations of digital electronics. In digital electronics, so many types of circuits are there. There are mainly considerable two factors are there. There are that is sequential circuits and combinational logic circuits. Combinational logic circuits are the logic circuits in which the output depends on present input only. Whereas in sequential circuits, the output depends on present input and as well as previous outputs. Okay, here with the introduction of sequential circuits. Sequential circuits are the backbone of digital systems requiring memory. Okay, in sequential circuits, memory also required. It is the main block in the sequential circuits. Yeah, you go. Unlike combinational logic, their output is not only solely dependent on the current input as well as previous outputs. Definition: a circuit whose output depends on the current input and a sequence of past inputs maintained by memory elements. It is maintained by memory elements in the sequential circuits. Okay. Memory dependence. The circuit state stored in 4 flip-flops or latches influence the next output and the transition. The mainly considerable circuits are in sequential circuits are flip-flops, latches, and counters, shift registers, etc. So many are there. These are the main considerable circuits. In this, memory element is mainly required in sequential circuits. Okay, this is the introduction about sequential. Here we go. The input is applied to the common logic or else clock pulse. In sequential circuit, the clock pulse is must and should. In synchronous, there are two types of you can see in later. There are two types are there, sequential, synchronous and asynchronous. But here we go with the basic block diagram of this sequential circuits. The input is applied to logic memory and the memory element, and here we go with the output. In this output, present it depends on present input and past output too. Okay. There are mainly 4 flip-flops are there. The flip-flop means it is a basic memory element in sequential circuits. There we go with the definition. A flip-flop is a fundamental 1-bit memory element in sequential circuits. It is a bistable device capable of storing a single bit binary digit. Okay. It is capable of storing only one bit, either 0 or 1. Flip-flop. There are 4 types of flip-flops are there. The flip-flop stores the binary information. There are 2 stable states in flip-flops. One is set and another one is reset, corresponding to the stored 1 and 0. The state is maintained until a specific signal is received. Okay. Unless there is no specific trigger signal is not applied, the state remains unchanged in flip-flops. Primary applications of flip-flops are the basic building blocks of more complex digital circuits like data registers and counters, shift registers, etc. These are the applications of flip-flops. The classification of sequential circuits. In sequential circuits, mainly 2 types of sequential circuits are there. One is synchronous sequential circuits, the another one is asynchronous sequential circuits. The synchronous sequential circuits are primarily sorry sequential circuits are primarily classified on based on state transition, time and control. Okay, the first one is synchronous sequential circuits. Okay, synchronous sequential circuits. It operates on clock pulse. That means the clock pulse is basically a square wave signal it is capable of, like we can assume that 0 1 0 1, like that is square wave clock means external trigger it gives to the sequential circuits. Okay, the operation. The clocked operation. State changes occurs at a discrete instant of time determined by a global clock pulse. That means the state whenever a clock pulse is applied to the sequential circuit, the state transition, that means the previous state is 0, or suppose you have to change the state to 1, then the clock pulse applied there are two types of clock pulses are there. One is positive edge triggered and sorry, edge triggering and level triggering. That means you can go with the, for suppose the clock pulse is like this. Or suppose this is a clock pulse, for example. In this uh, this is a clock pulse. In this is called level this is called paused edge. This is called level. In this is called positive edge. Here we go with some arrow marks, but I this is called positive edge and this is called negative edge. This is called positive level and this is called negative in the wave, in the full wave, but I have taken only positive level. But the most of the places the clock pulse is taken as edge triggering. That means it is used most of the flip-flops or sequential circuits combination, whatever it may be. Most of the clock is taken as edge triggered, either positive edge trigger or negative edge triggered. Okay. In this that means in this state uh, the state transition occurs only at this edge only, either 0 to 1 or 1 to 0. Only the state transition goes on this edge only. If you give positive edge to the circuit, the clock pulse that means the transition occurs only on positive edge. If you give negative edge, the transition occurs only at negative edge. Okay, they will go with SR and JK flip flops, the main two flip flops in, whereas the basic flip flops SR flip flop. Okay, the simplest type build using NAND or NOR gates. The SR flip flop is gates are sorry. The SR flip flop is a basic flip flop which is built with NAND or NOR gates. Inputs S and R. Set S means set and R means reset. Okay. Circuit issue. The condition S, the main circuit issue, that means drawback, is the condition S equal to 1 and R equal to 1 leads to an invalid state or in undetermined state in SR flip flop. That's the main drawback of this SR flip flop. For this, we have to rectify and make an JK flip flop. Okay, there we go with some inputs and outputs. In 0 0 inputs, the output remains no change. In SR latch, in SR latches, sorry, the output 1 1 1 0, sorry, it becomes set. That means from 0 to 1. If it is in 0, it will be set to 1. If it is already in 1, there it will be no change. In SR latch, the 1 1 remains unvalid or indeterminate. In this we have discussed SR flip flop. You go with the JK flip flop. The it's all it is the advanced. I mean, sorry, it is the next draw. Sorry, the drawback of the SR flip flop was rectified by JK flip flop. Solves the SR flip flops invalid problem. That means we have discussed that one condition in SR latch takes to an invalid state, that is rectified by using JK flip flop. Solves the here you go with the information. Solves the SR flip flops invalid state problem. Here was the inputs are J and K. Just very good. Toggle feature in this JK flip flop, the 1 1 condition leads to toggle and means it toggles from 0 to 1 or 1 to 0. That is called toggling. The when j equal to here go information, j equal to 1 and k equal to 1, the output toggles the flip flop on the edge, on the clock edge. Highly used function for counting. The main purpose of the JK flip-flop is used for counting. In this case, the JK flip-flop 1 1, that means the inputs 1 and the inputs JK are 1 and 1. The outputs goes to toggling, that means 0 to 1 and 1 to 0. This is about SR and JK flip-flops. Okay. And the next two flip-flops are D and T flip-flops. D means data or delay flip-flop, and the T means toggling flip-flop. Data D flip-flop means it simplifies this SR flip-flop by connecting S input directly to the R input through an inverter. Inverter means the NOT gate. It simplifies the SR flip-flop by connecting S input to R input through an inverter. It eliminates the invalid states, ensures S and R never be simultaneously 1, making the invalid state impossible. That means in SR flip-flop, the D is connected to S flip-flop, and R is connected with a buffer gate, buffer not, a NOT gate, that is resemble with, this is NOT gate, like this. Here we have bubbles, small bubble. This is called NOT gate. It is used for SR or R input. It is given to R input so that it simplifies the input directly to the R input through the inverter. It eliminates invalid states, ensures S and R are never simultaneously, making the invalid state impossible. Okay, the function of the D flip-flop are the output Q follows the input on the active clock edge. That means either positive or negative edge. Acts as simple delay element. That means in some cases some delay wanted is required for some circuits. Here the D flip-flops add some delay to the circuit. This is called D flip-flop. Okay, the T flip-flop means toggle. Toggle means here we can say the 1 1 condition in JK flip-flop. This is also similar to that one. In these two flip-flops, the input is there is only one input and one output. This is in this T also 0 1 input and one output is occurred. Toggle operation means if T equal to 1, the output flip-flops on the state clock edge is clock edge. If T equal to 0, the state holds. That means in toggling operation, if the input to the T flip-flop is 1, then the output on the clock edge is toggles. That means the output is already, if 0, then it toggles to 1. If the output is already 1, then it toggles to 0. If the T equal to 0 for the input, the state holds. That means it simply say you can say simply delay, like just D flip-flop. Yes, some small delay is added to it. The main key applications of T flip-flop is essential component in binary counters. This is also, as we say in the JK flip-flops, it is also mainly used for counters and frequency division circuits, where in output frequency is half the input clock frequency. Okay, this is about D and T flip-flops. There are two conditions, states. One is reset and another one is set in D flip-flop. There are two states in T flip-flop. There are, that is hold state and toggling state. This is about D and T flip-flops. Okay, next, the race around condition in JK flip-flops. The main disadvantage of the JK flip-flop is race around condition. That means the race around condition is a critical timing issue specific to level triggered JK flip-flop. The definition about race around condition is it occurs when the clock pulse duration is longer than propagation delay of the flip-flop. Every flip-flop contains some propagation delay. Okay, and some clock pulse duration. In this JK flip-flop, if the inputs are 1, if the inputs JK are 1 1, then it occurs the clock duration is then it occurs. That means the clock pulse is longer than propagation delay of the JK flip-flop. Okay, here we go. The triggering. When both inputs J and K are held, J equal to 1, K equal to 1, effects. During the clock pulse, the output continuously toggles. That means from 0 to 1, 1 to 0, continuously toggling occurs multiple times, and the final input is not constant. That means we cannot predict the output of the JK flip-flop, leading to unreliable circuit operations like that. Okay, this makes level triggered JK flip-flops impractical for high speed synchronous circuits. Okay, it makes the JK level flip-flop impractical. That means not using for circuits, high speed synchronous circuits. Okay, solution for master slave configuration. That means JK flip-flops, the solution for that JK flip-flop race around condition, we use master slave configuration. That means the master slave JK flip-flop is designed specifically to overcome the race around condition by separating the input and output processes. Here the master section contains when the clock is high, the master flip-flop is enabled and store the input J and K values. The slave is disabled. That means here we go with some blocks like 1 second. For suppose, sorry, this is about master slave flip-flops. In master slave, what happened means, for suppose this is master uh, block, and this is slave block. The input is applied to this like this, and the same input is applied to sorry, like this to slave flip-flop. uh, Here it is applied with a NOT gate. It is applied with a NOT gate. That means, sorry, sorry, sorry. That means it uh, for input one, the master is active and slave is inactive. For the 0, the slave is active and master is inactive. This is about JK race around condition and how do we rectify that. Okay, the next topic is counters in digital systems. A counter is a specific type of sequential circuit designed to cycle through a sequence of states, typically used for tracking events or controlling operations, etc. It is mainly used for counters. As we know, somewhere shopping malls, all these places, we have some counters. I mean, in this, not only the counters physically appear, the counters appeared in the every digital circuit wherever we. The mainly three types of counters are there: ring counter, twisted ring counter, asynchronous counter or ripple counter. The first one is a ring counter, a shift register where the output of the last flip flop is connected back to the input of the first. That means the ring counter last flip flop is given as input of the first flip flop. That means it forms a ring action, the finger ring or the ring action. That means examples, the that means the operation means it gives all it counts last for the last and comes back to the first input as well. That means from it counts from 0 to 1 to until we give a number like, for suppose, 1000. After the completion of the last clock pulse, it counts again to the reset. That means the first clock, the first one, it counts. The next one is twisted ring counter, or the other name is Johnson counter. It is similar to ring count, but the inverted output of the last. The in case of ring counter, the Q output is given to the input of the first flip flop, whereas in twisted ring counter, the inverted output, that is Q n bar, is given to the input of the first flip flop. In this twisted ring counter, for of the last stage, uh, the information is there here given. Last stage feeds the input of the first cycles through two end states. Okay, this is about ring twisted ring counter, and the last one is asynchronous ripple counter. Flip flops are the asynchronous counter or ripple counter. Flip flops are not clocked simultaneously. The output of one stage serves as the clock input for the next stage. That means the output of first flip flop acts as the clock pulse for the next flip flop. The simple design but slower due to propagation delay, because the clock is not simultaneously applied to all flip flops. The some delay is there, that's why it is not considerable for most of the cases. This is about ring counter, twisted ring counter, asynchronous counter. Okay. The next one is shift registers. There are two types of shift registers are there. One is left shift register and right shift register. In this case we are using D flip flops. In this D flip flops, the first the bit for suppose a 4 bit is taken as is taken, then the bit is shifting the first bit. For suppose if you take 001 for first clock pulse, in the next clock pulse, for suppose we take 0 0 0 1, for next clock pulse it means the shifting is occurring, uh, or else you can take 100 10, or suppose we take a 1000, for after completion of first clock pulse it shifts the 1, and after completion of next second clock pulse it shifts the 1 to another bit, and after completion of fourth clock pulse it shift. There are two types, one is left and right shift. That means in left shift register the shifting operation is performed in the left direction. That means in the left direction, either anti-clockwise. In right shift registers the shifting operation is occurred in clockwise direction. Okay, this is about shift registers. It is mainly used it is mainly used in the registers used in uh, sequential circuits. Mainly used shift registers in the sequential circuits. Okay, this is about sequential circuits. Okay. Thank you. Thank you, sir.